Hi there! I need to work on making a PCB for the power supply that I need for the synth project. I already talked about making PCBs at home in a previous video, but since this time I need several copies of it, I will use a different method that will easily allow me to do so. I will use this video to describe the process to make it, without entering the merit of the schematic itself, which will be anyway the subject of another video, and so you can use this approach as an alternative to the previous one to make more complex circuits without having to draw the traces manually. This process is very effective to make both single and double-side PCBs, which can be drawn using any of the free software tools that are available online. Let's get into it. Hi there! I am Carlo Carrano, and this is Electronics Engineering Made Easy. The basic difference between the procedure from the previous video and this procedure is the way the PCB is drawn on a copper clad. Instead of using a pen with an enamel ink, the so-called PCB pen, we print the image of the PCB on a special type of paper, like this one. This paper has a matte side, like regular paper, but has also a glossy side where the toner of a laser printer can stick, but at the same time can also be easily removed by heat or with a solvent. This paper is sold online in several places. Just search for PCB thermal paper and you'll find it easily. And I also have seen people having good results also with paper taken from magazines, those with glossy paper of course. Results seem to be equivalent. I used fritzing to draw the schematic of my circuit and also to arrange the components on a PCB layout. And actually I was able to draw all the traces on the bottom side of it, so I could use a single layer PCB, although the procedure works equally well with a double layer PCB. Once the schematic and the PCB designs were ready, I used the fritzing feature to export the drawings as etchable PDF for production. The process gave me a number of files to use. In my case, however, I just had to pick 3 of them: the etch copper bottom, the etch copper top, and the etch silk top mirror. I then used a tool to merge all the PDF files in a single one, so I could print everything on the same sheet of thermal paper and save some of it for the next time. Here is the result. This one on the top is the actual PCB layout with all its traces and pads. I will use the one in the center as a mask for drilling the holes in the PCB, since as you can see the PCB layout is not showing the actual position of the holes. If you use another tool instead of fritzing, you might be able to avoid that. The third part is the silk layer that I will transfer on the PCB top as a guide to position the components. I will use these drawings one at a time in the order they were printed, but in case you are making a double-sided PCB, you will have to use 2 drawings at the same time, one for the top and one for the bottom layer, so they can be etched at the same time. To transfer the drawing on the copper side, we first need to clean it, to remove any trace of copper oxide. This can be easily done with a piece of steel wool like this one. Just move the wool in a circular fashion to remove all the particles of oxide from the copper clad and make sure to use gloves, otherwise the contact with the skin of your hands will soon oxidize again the copper. Once all the oxide is removed, we need to deep clean the copper to remove any particle of dust from it, and to do so we can use some alcohol. Once everything is cleaned, let it stand for a few minutes to make sure the copper is totally dry, and then at this point it is time to transfer the toner onto the copper. I layered a thick sheet of aluminum on the table to dissipate the heat I was going to generate for the transfer without damaging the workbench. You can use some other method or even do the process on an ironing table, which is probably safer. Cut the part of the printed paper with the image that needs to be transferred. Align it with the copper clad and hold it in place with some masking tape. You may want to attach the tape only to the paper and not to the board like I did, otherwise you will have to clean the glue residues afterward. I learned the lesson the hard way, unfortunately. Once the PCB is wrapped with the paper, put it on the table copper side up, and use an iron at a max temperature with no steam to heat uniformly the whole surface of the paper and the PCB wrapped in it. Be careful not to burn yourself in the process, of course. You do not need to press hardly, the weight of the iron itself is just enough. Just make sure that you keep moving the iron so that the whole surface is heated uniformly. Do that for a while until the copper clad becomes almost as hot as the iron. And don't worry about burning the paper, it is not going to happen. Paper burns at 451 Fahrenheit, while the iron, even at the hottest temperature, doesn't normally go over 400 Fahrenheit. Once the paper and the clad are well heated, put aside the iron and unwrap the board, making sure that when you remove the paper from the copper side, you do that slowly and uniformly. As you can see, the toner, which is made of a plastic material, detaches from the paper and remains attached to the copper, creating the mask for the etching phase. You may notice some little imperfection in the transfer of the traces. If that is the case, use a PCB pen to touch up the area that need it. The more you master the procedure, the better the transfer will happen, and you'll soon have the skills to do a perfect transfer with no need for touch-ups. Proceed now with the etching using the same procedure I described in my previous video on making PCBs at home. Use a plastic container, fill it with some ferric chloride solution, enough to cover the whole PCB, and then dump the board in the solution. I recommend to use gloves to protect your hands. The ferric chloride could heavily stain your fingers if it touches them. And besides, if that happens, rinse immediately the hands with a lot of water to prevent the skin from absorbing the chemicals. And since we are talking about safety, make sure also that the solution does not get into your eye or your mouth. If that happened, wash thoroughly to clean the affected part, and definitely do not drink the solution since it is poisonous. Once the board is in the solution, you'll notice that the ferric chloride starts changing color. From the initial brown color, it starts becoming darker and darker. And this happens because of the copper of the board that starts dissolving in the solution. While the etching process continues, try to agitate the solution periodically, which will speed up the reaction. A warmer room will also help. Every now and then, check the status of the board and remove it from the solution as soon as you don't see any more copper on the surface of it. This process may last from 20 minutes to an hour usually, depending on the temperature of the solution and how fresh it is. All the solutions take more time to do the etching. For a faster process, you can try to put extra solution in the container and slowly put the board into it with the copper side down, making sure it floats on the surface of the liquid. This accelerates the process because the dissolved copper tends to go to the bottom, and so there is always some fresher solution in contact with the remaining copper. Either way, do not keep the board in the solution for more time than is needed, or otherwise the copper protected by the toner will start being etched a little bit at a time, and so check the etching status frequently to avoid that. Once the etching is completed, remove the PCB from the solution and start rinsing it immediately to stop the reaction that would continue to attack the remaining copper on the surface. And here is the final result after the PCB has been washed with water and dried. We now need to remove the toner film from the copper traces, otherwise we will not be able to solder the components on it. To do so, use a lacquer thinner or a piece of paper or cotton and work slowly a little bit at a time. Do this in a well-ventilated area, of course, because solvent vapors are both unpleasant to breathe and are also harmful. I have tried to remove the toner also using acetone, but it looks like it is too strong and has the tendency to quickly remove the toner from the traces, but it also sprays it on the fiberglass of the PCB itself, creating halos of black around the traces that are practically impossible to remove. It still works, of course, but the result is unpleasant to the eye. Using the thinner is slower, but works better, and actually to be able to remove all the toner, I ended up laying a few drops of the solvent on the PCB itself to be able to clean it well. And if you are up to it, you can still go with another round of cleaning using a piece of steel wool. And here is the final result with the first attempt using this procedure. I'm sure I'll get better over time now that I know a few more tricks on how to do that. Before drilling the holes in the board, we need to know where they are. Unfortunately, fritzing does not create pads with a hole in the center that can be used as a guide. However, it creates a mask that identifies the position of the holes. And so I took that mask, that I printed along with the rest of the PCB images, and I transferred it to the PCB in the exact same way that I used for the traces. And once I unwrapped the paper from the board, I got perfectly identified all the holes I needed to drill. Drilling the holes becomes now just a simple matter of using a fast drill with a bit of the correct size. While you drill the holes, just make sure that you use the drill at a maximum speed, and that you take your time to let the bit penetrate the board slowly. If you don't do so, you may end up breaking the board around the hole, especially on the opposite side of the copper. And of course, make sure you drill from the side of the copper to prevent it from detaching from the fiberglass while you make the holes. Of course, this cannot be done if you use a double-side board, because one side will always be on the opposite side of the drill bit. If that is the case, try to exert a very slight pressure when you drill, so that it will be always the rotation of the bit that excavates the hole, and not the pressure of the tip on the board. The drilling process in these images was done by my son. Unfortunately, I just came out of a spine surgery and I am not supposed to bend on the workbench for a few weeks until I am completely healed. But he was happy to help, and so I probably will ask for his collaboration for other tasks too, until I am able to do it again by myself. Once you are done with drilling, don't forget to remove the tone residues from the areas around the holes, otherwise it will become difficult to solder the components. You can do that, once again, with a solvent or with a steel wool, or both. And now that all the holes are done, we just need to do one last step, transferring the drawing of the component's position on the side with no copper, or in other words, applying the silk layer. It is still the same procedure as the other two transfers. Align the paper with the drawing to the board, wrap the paper around the PCB, hold it in place with some tape, and then hit the paper with an iron. Once the paper is hot and hopefully the toner has attached to the top side of the PCB, unwrap the board and enjoy what you have done. And now the PCB is ready to be used. Do you like it? I am going to make a few more of these boards to be used to build the power supplies for my synthesizer project, actually for our synthesizer project. You will see them used soon in another one of my videos. If you liked what you have seen and would like to continue watch my videos, don't forget to subscribe and to click on the notification bell so you will be informed automatically when new videos come out. And of course, don't forget to give me a thumb up. In the meantime, I'll see you in my next video, and as usual, happy experiments!